We are looking at Desmos geometry right now, and we're going to be doing some rotations of the parallelogram ABCD first. We want to first do a rotation with Q as the center of our rotation. So we will choose our transform menu and define a rotation with a center at Q. And we're going to do we're going to do one that is 90 degrees counterclockwise, or clockwise, I mean. So over here on the left side, this is showing counterclockwise. So instead of 90 degrees counterclockwise, we're going to do 270 degrees clockwise. And we need to select this and apply that rotation. And we have a new shape over here at the bottom right. So we can select points here to show that that has become the rotated version of what we started with. So you'd want to label the points that match with the proper labeling of A prime, B prime, and C prime. And down here we would have B prime, and we have C prime as well, and finally D prime for our fourth point. So we have finished our parallelogram here. We've rotated it by 90 degrees with the center at Q. For our second transformation, we are going to define a new rotation with a different center at R. The first thing to notice is that R is a little farther away from the original pre-image than Q was to the original pre-image, so that's going to change our outcome right there. So what we want to do instead, now we want to do 180 degrees with R as our center. And you can see that we have constructed that over here, and we can place points for A, B, C, and D prime on these corners. So we're going all the way around. So our C prime, the farthest away, is this new point. Our B prime is going around this direction, would be next. Our A prime after this rotation is there, and we have our D prime as our last one. So some things to notice is that when you're going 90 degrees clockwise, you have your shape down here at the bottom, but when we go 180 degrees around, we have kind of just a flipped over version of that same shape. We have a second shape now that's more of an oblong, sort of irregular polygon. And we're going to rotate around points P and O. So the first rotation we're going to do is 120 degrees around point P clockwise. So we are going to define a rotation around point P, and this 120 degrees clockwise would be 240 degrees counterclockwise for this polygon. And we have kind of going all the way around clockwise to here. And so if we can label some points on here that would match each other. So if we're going all the way around that way, 90 degrees this way, so the point on the end here, that would be point A prime for this shape. And we can compare the rest of the points from there. So if we do one more transformation instead, we're going to use point O as the center. We want to define that second rotation here as 60 degrees counterclockwise. So we would only need to type in the 60 there. And we want to apply it to this shape. And we can see we went 60 degrees around that way. And we can see how these rotations are kind of altering the orientation around that point, and you can kind of apply it, and you can kind of see how it goes all the way around the circle, kind of pointing in different directions as you go. And we can kind of take this and kind of rotate it around point P in those three places as well, with all these shapes kind of rotating around their unique centers. In this last Desmos geometry example, we have two triangles, ABC and DEF in front of us. Now, these two triangles look like they could be congruent or completely the same in layman's terms, but we want to confirm that using rigid transformations. Rigid transformations includes translations, reflections, and rotations. So we are going to try to see if we can get this blue triangle to be exactly on top of and the same as the black triangle using those three kinds of transformations. If I can, then we've confirmed that they are definitely congruent triangles based on that. So let's start that process. We want to use our transformations menu for the most part here since we have a triangle. We have this ray in red right there going through from A through D. And our first transformation is going to be a translation taking point A to point D. So we need to define our translation as going from point A along this red vector to point D. And we're going to select this whole triangle as what's being translated. So we've moved that triangle to right here in blue. So we have our second triangle, and we can make it green to differentiate it from our first triangle. So now we want to see, can I go from green to black still? Well, we aren't there yet because we can't move it around all the way. So what our next transformation has to be is a rotation. So I'm going to rotate this green triangle, and I'm going to rotate it around point D. But instead of going 90 degrees clockwise, I want to take it 90 degrees clockwise instead of counterclockwise. So instead of 90 degrees counterclockwise, I need to go 270 degrees clockwise. And I'm going to choose that green triangle to make that rotation happen. And now I have another triangle there. So let's select that green triangle and make it orange as our second triangle we transformed. Right now we have our original pre-image. Our green triangle, we'll call that triangle prime. Our orange triangle is triangle double prime after two transformations. We had a translation and then a rotation. Lastly, we're going to transform this orange triangle onto our black one by using a reflection. In order to do a reflection, you can see that when I click on this, I need to choose a line of reflection. Luckily, I have this black line segment right here to choose. And then I'm going to choose my orange triangle and reflect it. And you can see that that new orange triangle that I'm going to make gray has kind of gone right on top of our black triangle. And that shows that the blue and black were exactly the same, are congruent from the very beginning by using a translation, a rotation, and then finally a reflection. Thank you for watching this video on Desmos Geometry Constructions.